What building materials and assembly strategies are best to design this healthy and resilient medical campus in Blantyre, Malawi? What is resilience? Environmental resilience utilizes the vernacular materials of the region to minimize transportation and mass material manufacturing. This form of resilience looks at the amount of recycled content used, the recyclability and reuse of the material at the end of its life. Using materials in a sustainable manner maximizes building performance. Economic resilience looks at how the material benefits the local community's circular economy during construction and building use by providing work and income. Durability resilience takes the physical longevity of a material in itself and the combination of various materials to create the building tectonics. This type of resilience looks at the maintainability, durability, and upcycling potential of the material. Now that resilience has been defined, what is needed to achieve a resilient design for a site in Malawi? Construction materials that fit the local vernacular and have low environmental impact when producing the materials, benefits local economy as much as possible, and can withstand the tropical climate and requires little to no maintenance upon construction completion. Now, what program elements require different construction methods for this medical campus within Blantyre, Malawi? Laboratory spaces are the most constraining elements of the program, causing these spaces to need the most rigid and durable materials. Academic spaces can be expanded into multiple rooms and buildings to house the various support spaces of the laboratory. Elements such as classrooms, offices, conference rooms, and more main program spaces will be housed here. Flex spaces include the areas of the program that are based within the exterior elements of Malawi. These program elements may include pergolas, troughs, draining surfaces, and shaded seating areas.
Steel is an imported material, so while it is durable, it is much more expensive than other material options. The production of steel emits high levels of carbon dioxide, adding to the challenges facing the environmental impact that mass material production presents. Malawi has imported steel from multiple African countries in prior projects, but the cost for this construction is higher than other material options. The benefits of using steel within the structural frames of the laboratory space is based around the material's durability and sturdiness. This material can withstand many forms of weather and will last within a tropical climate. It's also fire resistant and will provide long-term consistent performance that will not rot, warp, split, or crack throughout its lifetime. Concrete is another imported material. It presents challenges around its high cost and unsustainable production methods with cement. There are factories within Africa that produce concrete, but it is still expensive to acquire in large amounts. Concrete is valuable to utilize as a material for foundations and floor slabs within the laboratory spaces that need to hold a lot of structural loads. Concrete tends to have low maintenance costs, which can make up for the initial high pricing. It's also effective in sound insulation and durability. And while the process of making concrete is not necessarily sustainable, the material itself is recyclable and can be reused in multiple ways. A building made of concrete has an overall low carbon footprint due to these post-production benefits. Gabion walls will allow air and light to filter through. However, it does require a steel structure. The use of stone allows for local materials to be used for wall infill. The construction of gabion walls is highly labor intensive, and the durability of the wall depends on how well the stones are placed within the wire baskets. Rammed earth can be a sustainable way to provide unique visual characteristics to a building. These walls are produced by layering and compressing different amounts of local soils containing aggregates such as gravel, sand, silt, and clay with a small amount of cement. Previously recycled materials such as concrete can be used in this aggregate mixture to strengthen the wall. Recent developments have found that by replacing the cement with a natural binding agent known as lime, the material becomes 100% sustainable and recyclable. However, the major issue with using rammed earth as a primary building material is that it is not load-bearing, so this material must incorporate structurally beneficial materials such as concrete or steel as additional components to the overall construction. Bricks are the most common building material in Malawi, which makes this the vernacular building material for this area. Used for centuries, different kinds of bricks have been utilized for anything from homes to schools to public buildings. They use local materials and labor, and bricks are cheap and quick to produce. Reusing old bricks can be a possible solution for landscaping materials, concrete aggregate, and filler for rammed earth walls. One of the largest issues with producing bricks is the effects of deforestation caused by kiln firing. Hundreds of thousands of tons of fuel wood are required to produce just under 2 billion bricks. At this rate, the entire country will be deforested within 30 years. There are various drying solutions to this common issue, such as sun drying. However, a common and more efficient way to dry bricks is through the use of a kiln.
Flex spaces are the program elements that are more connected to the natural elements of the exterior space within the site. These spaces can include pergolas, porticos, naturally shaded seating areas, troughs, permeable pathways, and areas of material growth that can later be used for harvesting and construction. One of these key materials for these spaces is bamboo. While bamboo is not native to Malawi, it is currently being grown just outside of the Lilongwe. It can be grown anywhere and grows quickly. It takes approximately 3 to 5 years for bamboo to be strong enough to be used in construction. Bamboo can be planted on site and grown in time to be used for this project. This material is also extremely cost-effective and would promote local jobs for years to come. In addition to its use in construction, bamboo can also be substituted for firewood to fire bricks instead of continuing to deforest large areas of land. This space is a flexible space that can be made up of smaller built structures, landscaping, or a combination of the two. Any material talked about earlier is up for use, however, bamboo is heavily implied in some form. This space will benefit from permeable materials that allow the rainwater to be guided to a rainwater collection system or to soak into the ground rather than flood. Now, each material has its benefits and pitfalls that need to be taken into consideration for the specific program element it is being used for. For example, some materials fit best into designated areas, but may not be suited for another area. Each material can be combined into various assemblies to create a dynamic exterior condition that can help dictate programmatic spaces. This proposed model example is a hypothetical resilient design that can be utilized within the design of the Malawi Institute of Bioprocessing.